Ahoy hoy, I'm Planetwalk, and today we are addressing the rest of D Marble's video that I looked at in my last video. So to recap the last video, D Marble failed to explain seasons on a flat Earth, and he would use maps which he would claim would be flat Earth maps, but were actually just projections of a globe, and he would use unfounded assertions. He still has 15 minutes left in his video, so I will be cutting quite a bit out to save on time. But anyway, let's get into it.
Here, I'm going to show you once again my trip to Alaska. You've probably seen this already, and just wanted to show you again that whole clockwise circuit. That's what I went there to prove, actually. You saw that tower there. You see the sun moving off into the distance, and then what we just saw there, there was points where the sun was off in the distance and then came right back. So simultaneously saw sunset and sunrise at, within hours of each other. So
D Marble and I must have been watching a completely different video, because I did not notice the sunset. The sun was above the horizon the whole time. Sure, it went behind a hill at one point, but I don't count that as sunset. Also, everything seen in that video is expected on a globe.
Anyone on Earth that could see the sun, okay, from anywhere on Earth, I could see the sun at the exact same time that they could. Okay, so right now, what we're looking at right now, this picture, seeing the sun in the distance at 1 a.m., the sun was actually over the Middle East, or what's called the Middle East. It was noon Eastern Africa time.
Again, all this is perfectly explained on the globe. No need to make up a flat Earth model. In fact, if you were to sell a ring laser gyroscope for about $20,000, you could go to Antarctica and experience the exact same thing that you experienced in Alaska. And the flat Earth model struggles to explain that, whereas the globe Earth model not only explains it, it actually predicts that that should happen.
And to me, in my opinion, the way that the Earth is set up observably, how the North Pole star Polaris stays in one spot seemingly, and we're told that it moves from time to time, or that another star has been the North Star and all that. We haven't experienced that, but we've been told that.
Oh yes, to see a different North Star for yourself, all you have to do is, I don't know, live 1,000 years. But the North Star being in the same place doesn't mean that the Earth is flat. It just means that it's really far away. But what about the southern celestial pole? Isn't that an issue for the flat Earth? He doesn't even bother to try and explain that. It's like it's impossible on a flat Earth or something.
We see the stars in these time lapses all make these concentric circles around the North Star, and that, in my opinion, would be an ideal place for the creator to sit and look down on the Earth.
Now, I'm not religious, but isn't God supposed to be outside of space and time or something like that? I mean, some people even say that he's everywhere. Why does he need to sit in a particular spot? Or maybe he does sit in a particular spot and he actually sits over the southern celestial pole to try and get away from all the flat earthers.
If you can make it to Alaska this summer at some point, I'd encourage you to do so.
D Marble, if you could make it to Antarctica at any point, I would encourage you to do so. In fact, I'd love to go in 2021.
Again, just a brief view of what that looked like. Okay, I kept my camera locked onto the sun, showed that the sun was making a 360-degree circuit around the North Pole.
But what about the videos in Antarctica showing the sun making a 360-degree circuit around the South Pole? And you don't have to take my word for it, you could go there for yourself and film it. If you don't have the money, I'm sure Bob from Globebusters would be happy to help.
Now let's talk a little bit about your visual perspective on a flat Earth.
Ah, perspective, the word that is bound to make any flat earther wet. Wait, what?
Now, this is an example of a little art project that we've all probably done, an art project, something like this. And this is from like a 6th grade art class, something like that. And this is the point perspective, Okay, what you would do, you would draw a point, on the paper, and then all the lines, the lines from the street, the lines from the sidewalk, the lines from the buildings, they would all converge into the vanishing point. And a lot of us remember taking this class and actually doing this project. At least I know I do.
And I'll do you one better. In grade 7, I learnt about 2-point perspective. And in grade 9, I learnt that it was very annoying that the Earth wasn't flat because perspective wasn't quite enough to cover up the things in the distance that should really be over the horizon by now. Although it was primarily because Google SketchUp didn't play very well with curved surfaces. Anyway, the point is that I didn't decide to just drop out of school at the end of grade 6. I actually continued my education. And because I continued my education, about 2 years ago, I have figured out a formula for perspective. And that formula is 360 times height divided by distance over 2 pi. Of course, the trigonometry version, the arctan of height over distance, is far better and more simplified, but give me credit, I did work out a formula for perspective by myself. And when you really think about it, half of my equation is just converting from radians to degrees, so it really could just be height over distance. Now, the formula that I came up with wasn't exactly the best formula. It does give a good approximation on objects that are small and far away, but objects that are large and close, not so much. But it is a damn sight better than whatever I've heard from any flat earthers. So the moral of the story here is basically try to use something that's beyond 6th grade. I know that may be hard for some flat earthers, but you can do it. Okay, maybe you can't.
Why would they have us do this art project this way? Well, that's because that's how your eyes really work. In reality, your eyes function just the same way. Your vision is shaped like a cone, if that makes any sense, okay?
So the reason why they get you to do things this way is because as things get further into the distance, they take up less space in your field of view. And this is not exclusive to the human eye. This also applies to cameras as well, which is what a drawing is usually trying to mimic.
Wherever you look, there's a point out in the distance, and all lines converge into that point. Okay, just like if you're standing in this hallway. This is the hallway, I believe, of a cruise ship. Now you're standing in this hallway and you're looking down and you see the walls going inward, you see the floor, it seems to be going upward, and the ceiling seems to be going downward. And you know that the hallway is the exact same size at the other end, but your perspective shows you that the further away that all the the distance is, as things get further away from you, the smaller they become, and they all converge into the vanishing point.
Now, here's an important point. Parallel lines going away from someone will never actually converge. They may appear to converge, but only when they are unresolvable from one another. Now, the part that I like about all this is this can all be figured out with maths. You don't have to make any guesswork of, oh yeah, it looks like this, so therefore it is this. And using the maths, you can determine if two objects are resolvable at any given distance. And D-Marble actually uses the maths! Just kidding, I wanted to see how many people would have heart attacks if I said that.
Alright, here's another example of street lights. You know all these street lights are the same height, same distance apart, but as they go away, they look like they're getting lower on the horizon. So what I did, I took sunset. What I used to do after work every now and then, I'd go to a nice relaxing spot, watch the sunset, and I've done live streams from this place, and I would record the sunset, okay? And it becomes blatantly obvious to anyone with sense that I was sitting still, and obviously it's the sun that's moving, it's not the earth that's moving. So what I did, I kind of faded the picture of the street lights with the sunset just to show the exact same thing. The sun maintains a constant altitude, and as it goes into the distance, it appears to set into the horizon, but it just goes further out of your view to a point to where you just can't see it anymore, and it takes its light with it. So that's pretty much how that works.
Except there's a flaw in your video, and that flaw is so glaringly obvious. Let me point it out. Ooh. So I hope that illustrated it. If it didn't, let me spell it out for you. When the sun is overhead, it travels at a normal velocity. As it gets further away, it mysteriously seems to speed up for some reason. And you can tell it's speeding up because it gets past more and more streetlights in a shorter amount of time. However, in reality what's happening is it's just appearing to move 15 degrees per hour. Kinda like Bob's gyro. Wonder what's up with that. Also, another very important thing is that when people take photos of the sun using a solar filter on their camera, the sun does not change in angular size. If it was getting further away, that would be something we would expect to see happen. But we don't.
And let's cover this.
Fantastic.
Oh yes, I remember that video. Greater Sapien did a lovely job addressing it, didn't he? I am going to skip over this part of the video because you do give a brief summary, and the brief summary is what is important.
What we experienced there was an example of what we're seeing here. Okay, it is possible that, well, here, you just have to imagine.
When someone says you just have to imagine, that doesn't sound good.
From your perspective.
Oh no, it just got worse.
On the plane.
I think D Marble just ironically summed it up perfectly. You just have to imagine from your perspective on the plane. Because the only way that Flat Earth makes any sense is in your imagination.
It was 6:06 a.m. where Luke was, high noon where I was at, the sun was high in the sky, and then it was sunset at the exact same time where Matt was. But you also recognize that it makes sense that we were all standing on a level surface. We're all standing on a level surface at 90 degrees looking at the same sun, and the sun's at a constant altitude. Matt's watching the sun go down, the sun's above my head, Luke's watching the sun come up. Okay? Nobody was upside down.
You had 3 people there. You could have definitively measured the angle of the sun on a flat Earth and figured out how high it should be. Then I would be able to take your calculations and show you that it still doesn't make sense on a flat Earth. Because I've figured out that if the sun is only 1,000 kilometers high, then it should never be anywhere near setting on a flat Earth. Even if it's only 500 kilometers high, it should never be setting on a flat Earth. And the lower that you want to put it in the sky, then the problem about its angular size just gets worse. Although that is assuming that you're able to measure the height of the sun on a flat Earth, because people have tried to do that, and they're never able to. At least not when they have more than 2 people. When more than 2 people are involved, like when Slice Bar Kane measured it with about, I think it was 10 or more people, then it is found that the sun is a long distance away and the angles can only be explained on a globe. So I'm sorry, but your observations make far more sense on a globe.
So it just depends on your perspective and your position on the plane.
Okay, if that is true, then answer me this. Why is it that at 6 PM on the Tropic of Capricorn during the southern summer solstice, can you see the sun, but at the North Pole, you cannot? Just by using the Pythagorean theorem, you can show that you are further away from the sun than the North Pole. So, what's going on there?
Does that make sense? I really hope that makes sense.
No, that doesn't make sense. You should really get someone to make sure it makes sense before you upload the video rather than having it as a question within the video.
Reality makes more sense when you can understand the progression of the seasons, when you understand the movement of the sun, and understand the perspective and the way that your vision works.
Funnily enough, I actually do agree with D Marble on this point. It's just a shame that Flat Earthers understand none of those things. Now, in the last video, at the beginning, I said, because this is for newcomers, I expect it to be convincing, and I hoped that D Marble would not disappoint me. He disappointed me. I mean, why would anybody be convinced by fucking wee? Also, a number of people realize that he barely has any comments on his videos, and the comments that he does have all seem to agree with him, and there's a perfectly reasonable and rational explanation for this. He holds all comments for review and only approves comments that agree with him. That's it. But anyway, that is it for another video. I would like to give a big shout out to my $20 or more patrons: What Jesus, Holmes, Hugh Jarsz, M.C.Nutkin, Wolfie, Stringer News 1, Ashpanash, Curtis Reynolds, and Morrie. If you want to support me financially, you can do so on Patreon. But anyway, I will see you in the next video. Between you and me, thank you for watching.